And here's an alternate method of putting a designer in your box. We're going to start with an image. So let's search Google Images. In this case, I'm just for example looking for a flower, and I'm going to click on Images. Now these kind of images would not be suitable for conversion. We need black and white drawing images, so you can click on this, and only some of these are suitable. This one is too complex, too complex, too complex. Also things that where there are kind of fuzzy lines or poor resolution aren't going to work very well. So this is flower drawing. You could also use a modifier called line art, and that would produce often better choices of images. You can see the lines are bolder and blacker than the ones that drawing chose. I'm going to use this one just for an example because it's relatively simple. So when you on the image, right click and then say open in new tab, and then let's go to that image, let's view that image, and now let's download that image. So we're going to save that as, and I've already downloaded it once, but I'll do it again, and it's a GIF file. Okay, so that's now in that folder, and we need to convert that to what's called a vector file. Okay, a little bit more on images while we search. So if we go line art, you can see something like a tree. In terms of what's suitable and what isn't, that would be fine. That's okay, okay, okay. Too complex, too complex, too complex and too much gray. That would be fine. You kind of get the idea. Things like this where there's large amounts of black, that's only going to have two lines, just so you know. There's going to be a line on that edge and a line on this edge, and there won't be lines in between. This is probably on the edge of complexity. Clearly too complex. So search for whatever you like that is appropriate to put on the box, and download that as either a JPEG or so your various file formats would be GIF, JPEG, PNG. Those are the most common, and I think we can handle all those. Alright, so now next that you have the file in your folder, you want to open up ProjectCAD. So ProjectCAD is on the all of the lab computers, and it has built within it, it has a converter to convert that that image file to a vector file. So image files, JPEG, etc., those are all called raster files. So they're made up of dots. Vector files are made up of lines, and that's of course how CAD works. So go to the Open ProjectCAD, and then go to the Add-on Tools menu, and then go to the Raster to Vector WinTopo. So this is a program that comes with ProjectCAD. So I'm going to click on that, and now WinTopo comes up. And let's see, let me bring this so it's the right size so you can see it. Okay, now we're going to open our image file. So let's find that. You can see a variety of ones I've already been trying. There's the one that I was using as practice. Okay, there's the image file. You can see it's made up of pixels or dots. And it has a very nice way of converting that's efficient. So go to the vector menu. Then first we need to set some options. Go to the Set One Touch Options. And this is all fine. The important thing is vector extraction. This checkbox must be checked. That's going to make a drastic difference in how complex the resulting file is, and it's very effective. You can leave the settings the way they are, or you can play with them to get a different result. So I'm going to say OK, that's the options. And now back in the vector menu, just click One Touch Vectorization, or F10. That did it, and the green lines are the vector equivalent of that raster file. So now that that's done, at least within the program, we're ready to export it. So we're going to go File, and then Save Vector As. So this is going to save the DXF file. And we have jasmine flower drawing 1, 6. I'm going to go just type this for my purposes so I can find it later. WinTopo. And we're going to say save. Okay, so now we're done with WinTopo. We can close that. And now we can open that file in Projicat. So there it is right there. And here's our vector file. So you can see it's a little bit rougher than the original, but a pretty good representation. It also made a few errors. You can see this turned into a gray line for some reason instead of a white line. So let's correct the errors and maybe we'll clean it up a little. Now this is very common when you have a conversion process that you almost always have to do some cleaning. So I'm selecting all of those lines and I'm going to convert them all to white. So there should be a menu right here, and you can say white there. That would be perfectly fine. You can also use this menu box. No, you can't. That's because that only has one layer. So we're going to say white, and that's going to convert them all to the right color. Now I'm zooming in here with the mouse wheel, and you can see there's a little extra line here. So this can be easily fixed. I click on that and I hit the delete key. We could also clean it up later within SolidWorks. Nothing wrong with that. So I'll just give you some examples of how you can clean here. Let's see. Now so this is a good example of the good job that WinTopo did of converting that to a sparse, what's called polyline. So there's not too many points on it, and that's good so that SolidWorks does not crash. I'll show you an alternate example. I'll open a conversion that was done online. I think this one was done online by one of the online converters. And it's very smooth, that's nice, but look at all the points. Just a massive number of points. And this is so many points that it would cause SolidWorks to crash. It often does. So that's the problem that I've found with the online converters, and I have not yet found a good way to take this and turn it into a sparse drawing. So that's the reason we're using WinTopo. Okay, so this is our converted file. You could continue to clean it up. For example, you could click this one if you wanted to move that a little bit. Just click on the vertice. Move it over there, hit escape to finish that. If you wanted to move this, I could go right click to select both of those, and then I could move that vertice and it'll move both line segments while I do it, so I can smooth that out. I can click that and move both those vertices. I can, let's see, I have a different kind of edit. I could change actually this whole thing to a smooth line. So let's see, if you want to, I'll delete these. So I selected from right to left to delete all of that. And then I go over to this tool, which is a 3-point arc, and I can replace that. Okay, now you remember in SolidWorks it would often grab onto a point. And the reason it's not doing that is I don't have one setting. Down here you see Entity Snap, eSnap. Make that white. And then it brings up an eSnap control box. I would suggest clicking Endpoint, Center, Midpoint, and Intersection. Say OK. And now when I hover the mouse near that point, it grabs it. That's very nice. So I'm still in this arc toolbox. Okay. So that's how you can clean things up. And we could do more of that, but for this purpose I think we're done. A few other things we want to do is check the scale and the location of it. So for the scale, if you probably don't have the dimension toolbar here. If you do, you could use that. But right down here, you see these this command window. So Projicat, AutoCAD, these are all text driven. Okay, so we're going to check the size of this thing. And so right in this text window, you can type dim linear, all one word. That's the command for a linear dimension. And now I can measure the rough size of it. I don't need to be accurate, I just want to know approximate. So it's set there, and you can see the units 220. So that's rather large. It's probably in inches. So let's change that and let's scale that. We could, of course, scale within SolidWorks as well. Sometimes it's nicer if you get it to a reasonable size beforehand. So I'll just show this. You don't have to do it if it becomes confusing. So I selected everything. Then there's this command called scale. So you can either type scale or hit that button. It's asking for a base point. That means the zoom point, if you will. Middle is fine. Actually, a better choice for the base point would be this, because there's another thing we're going to do before we send it in. This is the origin, and we'd like this drawing to be centered about the origin or close to it. It will make the import go better. So click the origin and that'll pull it there. Okay, and then a scale factor. That was 220. I'd like it to be about 2. So that would be a 0.01 scale. 0.01. And let's see. There it is right there. Okay, so it may be hard to find. And it looks like it did a bad job of remembering my little arc when it did that scaling. So probably we should do the scale first before we do the arc command. So let me fix that. Okay, so I went ahead and fixed that without the video running. Save some time here. And we're ready to now save this file as a DXF file that's ready to go. So that's the number of points, and that's a very reasonable number of points for our SolidWorks to import it. Okay, so now we're going to say save. And that file is now ready for import into SolidWorks. And I'm also going to close the file so that there's no conflicts between the two programs. And now we're in SolidWorks, and if you've already watched the video on how to import a DXF file, this will be mostly repeat. If not, just keep watching this one and you won't have to watch the other one. So we're going to insert, so in the insert menu, a DXF file. And first it asks for the plane on which we want to insert it, so click OK, click the plane, and now it's a little confusing because you don't know what to do and it's not telling you. What you need to do is hit the Enter key. So I'm hitting Enter, and now it brings up my folder, and so you navigate, in my case I'm already right where I need to be. You navigate to the file you want. You can see this is only a 24K file. Some of those other files are quite a bit bigger, 121. It's not necessarily the file size that's the problem. This came from the web, but it's the number of points within it. These logo files are fine. They're 150K files. So it's not necessarily file size, but this shows you what the WinTopo was able to do that the web programs were not. Okay, so that's the one we just saved. And it's now importing it, and we go into this wizard. So let's click Next first. There's our file. It says the units of the data. Well, we've already scaled it, so it should be fine at with an inch import because we made it a rough dimension of 2 within ProjectCAD. If you didn't scale it within ProjectCAD, you can roughly scale it here. Click on that and you can see you can scale all the way from angstroms to feet. So if, for example, it came in as 200 inches, you could select millimeters, and that would reduce it by a factor of 25. If you wanted to be bigger, then I would choose feet. So millimeters or centimeters would probably be your typical choices for rough scaling if it's coming in way too big. Okay, so let's click inches since that's already correct. The white background doesn't really matter. It will come in correctly either way. That just changes the background as you see it. Click Next. Now this sometimes is important. So we'd like it to be placed in our model reasonably close to the part we've already designed. So the question is, how do you, when we bring this in, the drawing had an origin on it. That was that little crosshair down in the bottom left here. This has an origin. It's going to match the origins. So we'd like to define the origin right now in case it wasn't correct. So click this Define Sketch Origin button, and then click, I would suggest, the middle of your drawing. And now you can see it, put it there. It was way off to the side, too far away for it to show up. And then you have to hit Apply for it to take. Okay. And you can also rotate the part if you want to here. We can do that later as well. And if you had extra lines that you had in your drawing, you could remove those with that button, but we're fine. So now I click Finish, and this should come in right there. Now it's a little big, that's no problem. When we use the DXF import, SOLIDWORKS automatically creates a new sketch, and so we are within the sketch right now. And the reason I know we're within it is I go up here, and Exit Sketch is an option that I could click, so I must be within the sketch. So it's a sketch that includes this DFX file, and I want to shrink this and maybe move it around a little. So I'll show you some other commands for that. First I'm going to select everything, so it's light blue and selected. Now I go to Tools, Sketch Tools, and the main ones we use are Scale and sometimes Rotate, and you could use Move, although it's easier just to move it by click and drag. So I'm going to use Scale because we need to make this a little smaller. Now I have a scale function coming up. It's already populated with all of the line segments, and it wants to know what point do you want me to scale it about. What's the zoom point, if you will. So click there, and then the middle is fine. Doesn't have to be exact in this case. And now you want to scale factor. The last one I did was 0.8, and so that's still in there. That looks a little big maybe, so I'm going to use 0.7, and that should make it a tad smaller. Okay, and now we'll click Check, and that is our drawing that is imported and placed onto the front face. Now some drawings you could turn into full cutouts. Most of them are only going to be suitable as etch lines, and I'll leave this one as an etch line. It would not know how to turn this into a cut because it wouldn't know, do you want me to cut that? And if you want me to cut that, what does this line mean if you also want me to cut that? Those are questions that have no answer, and so SOLIDWORKS would catch that and would say, it would give some kind of an error message. So we're just going to leave this as a sketch that's sitting independently in our model, and that will come through when we export to the laser cutter as something we can set up to etch on the surface. Okay, so that is the process for going from an image file and bringing it into SOLIDWORKS.